Hi everyone, in today's lesson we're going to talk about regression models. In order to do that we need to recall scatter plots. Basically what scatter plots are, they're a way to represent bivariate statistics. Scatter plots are simply a set of points scattered on the coordinate plane. Now what is bivariate statistics? Bivariate is just data involving two variables. So here are a few different scatter plots that you could have. You could have a linear regression model where the scatter plots actually look like they are forming either a positive line or a negative line. See these dots in here? This could look like an exponential decay or an exponential growth. This here looks like a logarithmic function. And we even could have a sinusoidal regression where one kind of looks like a sine or even a cosine curve. Now, there's one thing that we need to remember about scatter plots, and that is that the points will never be connected. So the points will not be connected. I mean, what you see here on this line, this is called a curve of best fit, or in this case, if I were to draw in a line here, it just means the line that best fits the data. So, I mean, I could even draw one here. See how it's not going through every point? These curves are the curves that fit the data. They're just so happen to be drawn in already. So don't be confused. I'm not connecting any of the points. So in this course, we will be talking about these two, exponential regressions, as well as sinusoidal regressions. And we're going to explain how to create them and how to analyze them. So let's move on to the next page and do the first example. Okay, example. The data at the right shows the cooling temperatures of a freshly brewed cup of coffee after it is poured from a brewing pot into a serving cup. The brewing pot temperature is approximately 180 degrees Fahrenheit. So if you analyze this data just for a second, times 0 minutes, the temperature should be approximately 180 degrees Fahrenheit, and then it should decrease as time increases. So as time passes, this hot cup of coffee is going to decrease in temperature. So what we're going to do now is look at part A and see what they're asking. It says, determine the exponential regression equation to model this data, rounding all values to the nearest 10,000th. How do I know that this is going to look like an exponential regression? Well, think about it. If down here on the x-axis is your time and the y-axis is your temperature, we're starting initially at 180 degrees. So we'll say that this is 180 degrees, and it's a gradual decrease. Will the temperature of this cup ever reach 0? Absolutely not. There's no way that if I take a cup and leave it on my desk and it has coffee in it that it's going to go down to 0 degrees. It'll go down to approximately room temperature, but that's about it. So this looks like an exponential decay model. So what we are going to do is try to find that equation. And the way that we can do that is use the calculator. So I'd like everybody to please follow along these steps. Take out your calculator and do it with me. So you want to hit Stat, hit Choice 1, and enter the data into List 1 and List 2. Resume the video, pause it once you've done that. Okay, then you want to hit Stat. You want to move over to Calc, and you want to select 0 for exponential regression. So after you do that, this should appear in your calculator. In X list, you're going to put L1, Y list, L2. Frequency list, you can leave blank because we don't have one. And the store reg equation, that's what this means, store the regression equation, you can leave this blank as well. We're not going to take care of that, but just hit calculate. And then once you do that, you should get this equation. So what they're doing right here is they're telling you what the form is going to be. It's going to be y equals a times b to the x power. Now I know this times and that x kind of look the same, so we could write it as a parentheses b to the x power. This is what your exponential regression model should look like. And look, they give you what your A value should be, and they give you what your B value should be. For purposes of these classes, we're not going to use the R and the R squared. You may not even have that on your calculator, and that's fine. So now can we make our exponential regression equation making sure that we round all of our values to the nearest 10,000th. That's 4 decimal places. So what's going to come first is your A value, so A here. So we've got y equals 171.4617. Now your B, 0.9882 to the x power. So this is your exponential regression equation that shows the temperature of this cup decreasing over time. Okay, now let's move on to part B. Part B says, using the exponential regression equation found in part A, predict the temperature. What variable is that, x or y? You should be telling me y. So you want to predict the temperature, y, to the nearest whole number at the end of 1 hour. Now if you look at the chart on the previous page, the time is represented in minutes. So our hour is really 60 minutes. And that is our x value. So we want to find y, so we're going to leave y, when x is 60 minutes. So 171.4617.9882 to the 60th power. Now, in order to answer this question, all you have to do is plug that into the calculator. So pause the video, plug it in, and then resume when finished. Okay, you should get approximately 84.1, and if we round it to the nearest whole number, approximately 84 degrees Fahrenheit. So after an hour, the cup decreases to about 84 degrees. Now, the second part of the question says, is this interpolation or extrapolation? So I've defined what those words mean here. So to interpolate data means to estimate a data value that is within the given data table, and to extrapolate data means to estimate a data value that is not within the given data table. Now, what do I mean by that? The given data table is on the previous page. And on the previous page, we go from time equaling 0, so we'll say x, y. We go from time equaling 0 to time equaling 50. So where does 60 minutes lie? 60 minutes lies outside these given data values. So we would say that this is extrapolating. So this is extrapolating the data because the value of x equals 60, the time value of 60 minutes is outside the given data table. Okay, now let's move on to part C. Part C says, using the exponential regression equation found in part A, so the same equation, predict how long to the nearest tenth of a minute that it would take for the coffee to reach 138 degrees Fahrenheit. 138 degrees Fahrenheit is a temperature, so this is your y value. So we're going to plug in 138 degrees in for y, and we want to find how long it takes for it to reach that temperature. We want to find x. So if my memory serves me correctly, we want to solve for this exponent. And the only way we can do that is by using logs, because logs are inverses of exponentials. So remember, we have to isolate the base that's attached to the exponent. So we're going to have to divide the 171.4617 on both sides. So on the right-hand side, we're left with 0.9882 to the x power. And when you divide the left-hand side, you should get 0.8048 ... Please, as I'm doing this, pause the video and check to see if your numbers are correct. Okay, so now we have to get this x by itself. And the only way that we can do that at this stage is log both sides of the equation. So we're going to log 0.8048 ... and we're going to log 0.9882 to the x power. And if we remember, if a power is given, we can drop it like it's hot. So x times log of 0.9882 equals log of 0.8048. Now to get this x by itself, the last thing we have to do is divide log of 0.9882 on both sides. Now when you're putting this side into the calculator, make sure you still have all of the decimal places and you're using second answer so that you're as most accurate as possible. So when you do this, you should get x is approximately 18.29 dot 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 dot. So if we're rounding to the nearest tenth of a minute, it's going to take approximately 18.3 minutes for this cup of coffee to reach 138 degrees Fahrenheit. Now, my last part of the question, is this interpolating or extrapolating? Well, again, we have the table of values, the x, the time, which goes from 0 minutes to 50 minutes, and then we have the temperature, which goes from approximately 179.5 to 100.5. So where does the data value of 138 fall? It's right smack in the middle. 138 would be somewhere around here. So we would say that this is interpolating. So we are interpolating the data because the data value of y equals 138 is within the given data values or given data table. Okay, you ready for sinusoidal regression? Okay, so let's read the example. The average daily temperature T in degrees Fahrenheit in Fairbanks, Alaska is given in the table. Time T is measured in months, with T equaling 0 representing January 1st. Write a trigonometric model that gives T as a function of T. So that gives the temperature, in other words, as a function of time. Okay, so this regression model is going to work in the calculator pretty much the same way as the previous example. This time I want you to determine the sinusoidal regression model to fit the data. Find all values, round all values to the nearest thousandth. So we're going to input this data exactly the same way we did the exponential. If you need the steps, they're here. But once you input the list into L1 and L2, instead of hitting Calc Exponential Regression, you'll hit SIN Regression. So pause the video until you're up to this point, and then hit resume when you're done. Okay, you should get this in your calculator after you hit Sin Regression. Now this iteration is 3. Leave it. It's a default. We'll never change it. The X list and the Y list are L1 and L2, as always. Period, we're going to leave blank. Store regression equation, we're going to leave blank. So the 3 stays, and these 2 we leave blank, and then just hit calculate. After you do that, you should get this as your model, where you have your A, B, C, and D values written here. So it's very simple. All we're doing is letting the calculator do the work. So if I want to write this sinusoidal regression model, rounding everything to the nearest thousandth, I'm going to take these A, B, C, and D values and round them and write them nicely. So take a minute and then hit resume when you're done. Okay, here should be your answer. Okay, here it is. So we're going to now use this equation to interpret the data a little bit. So using this model that you made in part A, can we determine the temperature T in Fairbanks, Alaska on April 1st and December 1st? And we want to find out if we're interpolating or extrapolating the data. So we first have to figure out what T values April 1st would be and what T value December 1st would be. Now I think we might need to just write this down on the side. So we said that January was T equals 0. That means February is T equals 1. March 1st is T equals 2. April is T equals 3. And then if we follow this pattern, December is going to be T equals what? What do you think it would be? It should be 11. If you go by the pattern with April, April's time is T equals 3, when the month of April is really 4. December was really 12, so it should be 11. Okay, so what we're going to have to do is use this equation and plug in For April, t equals 3, and for December, t equals 11. So take a minute, see if you can plug them into the calculator and see if you get the correct answer. Make sure, though, just like when we did the Ferris wheel problems, that your calculator must be in radians. So make sure your calculator is in radians. So calc must be in radians, okay? Very, very important. Okay, here are the solutions. Okay, if you have any questions at this point, please jot them down and ask us tomorrow in class. Okay, have a good night.